What's up, everybody? Oh, sorry, Barry McBarrington was on my shoulder there. Let's just say that I wanted to walk you through now how to do the how to get the image in here with the triangle. So here I'm just at geogebra.org/classic. You don't even have to download the application because you can do it all online now. So I'll post this link for everybody doing this assignment. You're just going to click the plus sign and image. And I can go to now I just downloaded a photo that I wanted. So I'll use that. Okay. So now I got my photo uploaded here. So I'm just kind of winging it here, but there's me getting my coach on in the huddle. You can see just we're about to pull out the victory, run away with a good one here. You can tell just trying to drop some knowledge in the huddle. Thank you for all those players who are listening intently. But what you can do here is you can insert a polygon. So in this case, I didn't measure anything, but it looks like it's about there to the floor, right? And I'm trying to find how far away Jude Staples is standing from me, because I've been trying to get him to, really bring it in and focus in the huddle. What I do know is I do know that this side, because a basketball hoop is 10 feet, let's say I'm just standing right under it, what I can then do is if I get back on my pointer arrow here, I can click on that and you can see this is segment E. And I can even go in to segment E and I think I click on settings. I can add a caption. I could write that segment E. I could even change it to height and I could say it's 10 feet. And what you can see now is that it shows up here as 10 feet. The thing that's tricky here is I still don't have enough information. I hope that this is 90 degrees. But what I could do is I could even test out the angle by doing this. And I can see that it's still not quite 90. So I'm about a couple degrees off, but that's pretty darn close. If that's 270, that means the interior is 90. I guess I should have gone the other way around. Maybe I should go here. I should click 1, 2, 3. And it tells me 89.91. That's pretty darn close, right? So all of this I may have to just eyeball it. So now I actually have enough information. If I know this is 10 feet and this is, or actually, sorry, I don't have enough information because that's the right angle. I need to get one of these. So why don't we try to figure out this angle from Jude Staples? Did I misclick? Oh yeah, I did misclick. Let me delete that. Let's say that I'm trying to find now the angle from Jude's sneaker up to the hoop. Oh my gosh. Sorry, I keep messing up. Well, I guess it's better I mess up. Maybe if I just click right here on the triangle, will it tell me? The angle measure? Let me try this again. So I click angle, bam, bam, angle measure. I thought you had to click 3, Whoops. If you ever make a mistake, you can just hit escape and it'll get rid of it. Maybe I'm just misclicking. Let me try one last time. I mean, it did give me that this is 27, so it actually gave me information I wasn't trying to find. Oh, there. I guess I just was not clicking precisely enough. I think if I click on this, I can move it so it's not getting stuck behind. So that angle is 62.85. I actually calculated the other angle by accident, but let me just, I could delete this because that was accidental. But now if I wanted to find how far Jude is from me, I could always just say, well, this is the opposite and this is the adjacent. So I could do the tangent, so TOA, opposite over adjacent. I could say the tangent of 62.85 degrees equals 10 over C, or D for distance, whatever you want to call it. And I could use the trig ratio to find that value. I could then also, say that, well, if I wanted to find the hypotenuse, I could say the sine, so opposite over hypotenuse of 62.85 is 10 over h, or d, whatever you want to call that hypotenuse. And I could find this distance from Jude's heel to that, assuming that this length is correct. And that's how you're going to use trigonometry. And if you look here, here's one of my students from last year who did quite a nice job with it, photo and masterman. This is Nia Weeks. She's a lovely person. Hopefully many of you know her and get to work with her. But what she did, she measured, she was 3 feet at the bottom of the doorway, and she found all of the information that she needed to find all of these other measurements, estimating that um, the height of the doorway was about 8 feet. The diagonal was about 8.5, the hypotenuse, and found the cosine ratio um, of I guess that's her theta symbol there, to be 3 over the 3 over the 8.5, gave her the same ratio that she had before. So she just ended up using all three trig ratios to show that those relationships worked. And if you see, oh, this is what she did here. She did the cos of 69 in her calculator and then did the ratio herself and found that the ratios were the same. Quite impressive work. So, and I said, it seems like a pretty reasonable measurement. So that's sort of your assignment here. Do as much as you can with it. Feel free to message me as you have questions, but hopefully it's fun to get some photos. And what you could do is, if you want to put in a Google Doc here like Nia did with her calculations, once you're done making it like I've done here, let's say, then I could just go, I think here I could say export image. And that way when I click, oops, my computer's being a little slow, export image, come on. And then I just download it, and then I can have that image and put it in a Google Doc. All right, I hope this helps. Hopefully you can have a little fun. And again, I don't think it'll be too heavy, but it'll be kind of interesting. If you want to do more than one photo, you may. If you want to use a photo you found online, if you want to draw an image, if you want to make a model out of some blocks or something like that. What you're going to just need to do is have one measurement that you do know, and then you could use GeoGebra to find the angle. So hope this helps for everybody. Let's download this. And then I could always put that PNG into see some of these different ones in the past. Here's Chen Jing. She did a really nice job finding the stop sign. Here Tina did a nice image. So if I created a new one, I could just put that image in there. Bada bing, bada boom. Huapa. Hopefully it shows up. Oh my gosh. What the heck? I thought Google Docs was smarter than that. I guess I would just have to, let's see if now that's fully loaded. Come on, Google Docs, how smart are you? It looks like it's working now. So you can drag and drop it. Now I accidentally had that point over there from my clicking on Geogebra. Hope you enjoy it. And let me know how it goes. Reach out anytime. Sorry I got a little behind. I promise I owe some other videos to people, but I want to get this week's assignment up first. So I'll get those videos done tonight. It's been a little hard to keep up with the graded learning now, but I'm trying my best. Feel free to reach out. Love to hear from everybody. Much